Here's a scene that might feel familiar. Your team wants to ship an AI feature. The GPUs you need are scarce. The CFO wants a clean forecast. Compliance is flagging data residency. Facilities says the nearest region is power constrained. The cloud is starting to feel heavy. Literally. The headline behind that feeling is simple. AI has moved from a workload on the cloud to the workload that's reshaping the cloud. Analysts now project that by 2026, the biggest cloud providers will spend well over $600 billion on infrastructure. And estimates suggest most of that is earmarked for AI systems, not generic servers. Let that sink in for a second. So what actually changed? And how should you think about cloud decisions right now? We'll keep this practical. What's different, why it matters, and a few takeaways you can use. First, a quick orientation. When people say AI infrastructure, they're talking about accelerator-heavy servers, GPUs, custom chips like TPUs, packed with high bandwidth memory, connected by ultra-fast networks, and dropped into data centers designed for high power density and liquid cooling. In other words, not your standard web app farm. Here's the thing. Training large models and running them at scale need massive parallelism and very tight node-to-node timing. That means big, dense clusters that pull serious power and dump serious heat. The cloud, which used to be about fungible CPU instances, is being rebuilt to serve these few, very demanding jobs. Analysts across banks and research shops see a step change. From 2024 into 2026, they estimate hyperscaler capital spending rising sharply, with 2026 crossing that $600 billion mark and roughly 3/4 tied to AI infrastructure. It's a projection, not a done deal, but multiple sources are converging on the same shape. Some even expect Amazon, Microsoft, Google, and Meta to approach, or in some cases exceed, about $100 billion each in annual spend around that window, with Oracle ramping from a smaller base. Now let's slow that down for a second. This isn't just bigger budgets, it's different budgets. Cash is flowing into accelerators, memory, specialized networks, power gear, and cooling, rather than into general x86 fleets. Providers have even leaned more on the debt markets to fund it. That shift echoes into pricing, availability, and where new regions get built. This is where people get surprised. Power and permitting have become hard limits. The question isn't only, do we have space and capital? It's, can the local grid deliver the megawatts, and will regulators approve upgrades in time? In several hubs, grid connections now take years. So instead of popping up regions wherever land is cheap, providers are chasing power, water, and political patience. Think of AI regions like power plants for computation. They need their own substations for electricity, cooling towers in the form of liquid systems, and transmission lines in the form of high-speed fabrics between racks. Traditional VM regions look more like office buildings, lots of rooms, modest utilities, easy to replicate. Overlay another force, sovereignty. Data sovereignty means your data is governed by the laws where it lives. In practice, regulators, especially in Europe and other strict jurisdictions, are pushing for sovereign cloud options, region-specific or partner-operated environments with local control. Some analysts use the term geopatriation to capture this flow back into national jurisdictions. The practical effect? Architecture is now shaped by law and policy, not just latency and cost. So, what does all of this mean for teams in the trenches? First, on economics. If most CapEx is flowing to AI gear, providers will likely try to monetize GPU hours aggressively. Expect premium pricing for the newest accelerators, more nuanced pricing on managed AI services, and maybe a slower pace of price cuts for vanilla compute in some places. We've also seen cloud infrastructure services overall growing fast. Industry trackers put Q3 2025 at around $100 billion for the quarter, up roughly 25% year over year, with AI cited as a big driver. The key thing here is that your cost curves may shift faster than your budget cycles. Second, on architecture. The center of gravity is moving from monolithic stacks to composable ones. A lot of enterprises are rethinking VMware-centric private clouds after licensing changes under Broadcom. That's pushed interest toward open stacks built on KVM, the Linux hypervisor, and Kubernetes, which gives teams more control and portability. Third, on hardware choice. There's a visible push to avoid single-vendor GPU dependence. NVIDIA still dominates, but you'll hear more about AMD, Intel accelerators, and custom chips. ARM-based servers also show up more often, especially for scale-out, power-sensitive work. The subtext is resilience. More options, more negotiating power. Let's make this concrete. Imagine you need to train a model on the latest GPUs. The nearest AI-dense region with those chips might be in a different jurisdiction than your customer data. So you end up with a split design. Sensitive data stays in a sovereign environment. Anonymized or synthetic data flows to the AI hot zone for training. Inference runs closer to users on smaller accelerator pools. It's workable. It just requires intentional data pipelines and careful governance. Or picture a platform team that's run VMware for a decade. Licensing changes land. Instead of just paying more, they spin up a multi-year shift to KVM under Kubernetes, keep a toe in multiple clouds, and standardize on a mix of NVIDIA and AMD GPUs. They also start testing ARM instances in the public cloud to improve performance per watt on certain services. The goal isn't purity, it's optionality. So, step back. The story distills to three forces shaping cloud decisions. AI economics, GPUs, memory, and fabrics dominate CapEx, so GPU time becomes the premium. Physical limits, megawatts and cooling, not just rack units, gate capacity. Sovereignty. Laws and policy decide where data and workloads can live. In other words, the future of your architecture depends on chips, physics, and borders. There are risks and open questions. Will this CapEx wave pay off fast enough? Some analysts worry about utilization lagging the hype. Debt-funded build-outs introduce leverage risk if AI monetization under-delivers. Power is political. Community pushback, decarbonization targets, and transmission project delays can slow rollouts. Lock-in is another issue. If you rely too heavily on a single GPU vendor or a proprietary AI platform, changes in pricing or licensing can force disruptive pivots. And then there's fragmentation. Sovereign clouds solve compliance but can splinter global operations. The technology roadmap is changing quickly too. Today's flagship accelerator can look dated before it's fully depreciated. Let's ground that. None of this says don't invest. It suggests investing with eyes open and with escape hatches. Looking ahead, a reasonable scenario is a stratified cloud. A small number of AI-dense core regions host the latest accelerators and fabrics. A larger ring of conventional regions focus on storage and CPU-heavy workloads. Edge and telco-adjacent sites handle latency-critical inference. Sovereign clouds mature into federated models, local control over data and identity, plus selective access to global AI models through standard APIs. And inside enterprises, power and geography become design inputs. Not just which region is cheapest, but which site has sustainable megawatt headroom and the right sovereignty profile. Multi-accelerator stacks will likely feel normal. Schedulers, observability, and developer tools will need to treat GPUs, custom AI chips, x86, and ARM as interchangeable building blocks. Open-source tooling, Kubernetes, KVM, open networking, keeps gaining ground as a stable substrate across private, public, and sovereign footprints. Signals to watch, hyperscaler CapEx guidance and utilization metrics, regional power pricing and grid upgrades near big data center hubs, new sovereignty regulations, and, importantly, signs of pricing power or price discipline in GPU-backed cloud services. If you're exploring this space, here are a few practical takeaways. Map your constraints first. Start with sovereignty and power. Which datasets can legally move? Which regions have realistic megawatt headroom for the next 3 years? That map drives every other choice. Separate your AI tiers. Treat training, low-latency inference, and background inference as distinct placement targets with different cost and hardware needs. You'll get more predictable performance in bills. Build for multi-accelerator from day one. Use abstraction layers, container runtimes, and schedulers that can target NVIDIA, AMD, and others. Even if you start with one vendor, having the option matters. Pressure test price exposure. Work with FinOps to model a premium on AI instances, plus the impact of region-specific pricing. Run sensitivity scenarios so a change in instance price doesn't break your plan. Lean on open building blocks, where it makes sense. Standardize on Kubernetes, KVM, open observability, and open APIs. It's not ideological, it's about preserving exit routes if terms change. Pilot an alternative path. If you're reevaluating virtualization after the VMware changes, run a small real migration to a KVM-based stack. If you're GPU-constrained, pilot ARM for suitable services to save watts where you can. The thread through all of these is simple: flexibility, efficiency, control. Flexibility to pivot vendors and regions. Efficiency that includes power and cooling, not just instance size. And control over the parts of your stack that matter most to your business. Before we wrap, let's summarize. AI has become the economic center of the cloud. Projections for 2026 show unprecedented CapEx, with a large majority flowing into AI-specific gear and AI-optimized facilities. The physical world is now in the loop. Power, cooling, and permitting are gating factors. You can't plan capacity without thinking in megawatts. Policy is part of architecture. Data sovereignty and sovereign cloud offerings are moving workload placement from global by default to federated by design. If you anchor on those three ideas, the rest of the decisions, multi-accelerator strategies, open-source stacks, region choices, start to click into place. The cloud isn't going away. It's being refactored around AI, energy, and sovereignty. For teams that treat cloud as a strategic system, one that evolves alongside the physics of power and the politics of data, this next phase is manageable and maybe even a competitive advantage. That's the story for now. If this was helpful, consider subscribing for more tech insights. A like helps us keep making these videos.